Hey guys, this is Sam with Nexus Workshop, and in this video we're going to talk about networking as it pertains to escape rooms. Networking is obviously a huge topic with a lot that goes down into it, and I am not the expert to give you the full rundown. But I have been around the block a good bit throughout my production career and into escape rooms and all the other immersive entertainment things. Networking has been a huge part of it, and we've done a lot of things with it. So I am in a good spot to try to tell you maybe some of the most important things that you need to know. So as we get about networking, the first thing we're going to talk about is your router versus a switch versus a hub. And as you start to look at these, if you look at guides online and things, you may see mentions of a network hub. Honestly, you can ignore network hubs. They don't exist anymore as far as I'm concerned. They have been completely replaced by switches. So you have really two main networking devices that you're going to be dealing with. A network switch, which is the box with all of the connections on it that you plug your network devices into, and a network router, which in this day and age probably has Wi-Fi on board. It is probably the main thing that you have. So you can really look at it as the router is the thing that actually has the sort of brain that is helping all these devices communicate to each other, and the switch is typically more of just an expander or the ability to have multiple things out there. You can do a lot of things without a router. If I'm doing it, I'm going to go ahead and throw a router with Wi-Fi on there just because that's the base for everything. I also am going to want to bring internet into that router. So even though nothing requires internet, it is a whole lot easier with my life as a tech for me to be able to connect to one network and do everything I need to do on that one network. That one has internet for me. It has my connection to my devices and all of that in one place. And the router is what's going to make that manageable. It's going to handle a lot of that for me. A lot of it just out of the box. In its simplest use, most of the time I can have a Wi-Fi router. I can set it up, set my password for my SSID. The SSID is the name of the network. The password is how I secure it. And it is important that I do secure it. Your network is your security as far as I'm concerned. You'll hear me talk about it in other videos where I'll mention on MQTT or on the actual devices themselves. I don't always feel like you need passwords per se, but you do need it on your network. Your network must be secure. Trust me, just put a password on that. With that Wi-Fi router, I'm assuming it's a Wi-Fi router. It should be a Wi-Fi router. They're pretty affordable these days. You can get pretty decently cheap ones. One of the things that you can look for are ones that have some form of mesh ability. One of my favorites that I've been putting in recently is some of the Linksys ones, where they're about $100 for the router, which is more than a lot of routers are at this point, but it's a good, nice router that can handle a lot of devices. And then it also has what is called an AI mesh, which lets me put multiple of them out there. I can hardwire them to each other, and then that will let a lot more devices connect onto my network, because as you have the limited number of antennas, especially if we're talking Wi-Fi, there's going to be times where they don't want to handle more than X number of devices, and that's not super well defined. It's not as easy as, yes, I can handle 12, or I can handle 20, or I can handle 100. They don't give you clean numbers like that. They just kind of stop working at some point. And that is something that you can see, especially with Wi-Fi, that you will literally have devices that all of these are working fine and these won't connect today, and they just can't get them online. And a lot of the time that is a number of devices issue. And if you add another endpoint, another AP as it is, then you can increase that number, and it'll basically start to bridge off, and it'll connect these 20 to this one, these 20 to that one, that sort of thing. That said, in networking, whenever you can, hardwired is going to be best. Wi-Fi works, it does, but especially when we're talking in the microcontroller realm inside of these rooms, it is definitely less reliable and more up to issues. I find that a lot of the time things like your computer or your TV or your streaming box, those things tend to recover pretty well, and they tend to hide and mask issues that do present themselves when you're dealing with more individual little components. Sometimes they're just not as forgiving. So hardwire when you can, and that is one of the great things about the Nexus Prop Controller, is it has hardwired Ethernet on board, plug it in, and you're good to go. Whenever you can, use hardwired. It will save you a lot of issues. We'll help with some troubleshooting network stuff, but we can't troubleshoot that much with you. So if it comes down to, hey, this thing is dropping offline and you tell me that you're using Wi-Fi, at some point I'm going to tell you, great, you got to try hardwiring it. That's the next step to see what's really going on. In your router, it is going to have a concept of IP addresses. So the IP address is what the device responds with. It is kind of its name. There's an underlying one where it has a thing called a MAC address. The MAC address is something that doesn't change usually. That's something that's usually like baked into the chip, and that is what it is. Some of the small devices actually mimic their MAC address, so they don't really have one. They just kind of say this is my one, but it should be something we can consider immutable. That's the device. MAC addresses are hexadecimal, so it's going to be a series of pairs of letters and numbers. It's going to look wild and crazy to you. It's not very human readable, and it's not really used very much. At a technical level, it's used down in layer 2, but that's just technical, and it doesn't really need to come up very much. But a MAC address is something that will help you find the device later on the network if you can't figure out where it went or what may have happened to it. One layer better than that for readability is the IP address. The IP address is largely what we're going to use when we find these things, but the IP address changes. The IP address can be something that is given to it by the router, and I would suggest you let it do this. It's something that can do it automatically. You can't have two devices on the same IP. You will get lots of problems if you do. The router is the main overall thing that's managing all of this, and will keep it all straight if you let it. So you should use it whenever you can. That is a process called DHCP. That is how the router is going to give different IP addresses to everybody to make sure that there's no conflicts. It's going to act as the DHCP server. It will serve those up. There's also a concept called static IP addressing, which is where a device itself can say, this is my IP address, and that's what I'm going to use, no matter what you say. Sometimes you had to use that, especially in the old days when you wouldn't have a DHCP server, where you would have to use static IP addressing and just tell everything what it should be, and then that worked. Today, it's built into your router. You should use it. If you set static, there's more opportunity to have mistakes and to create collisions there that will cause problems. There is another concept called DHCP reservation, where I can tell the router, hey, always give this IP address to that device. I don't find that you typically need this, but if you have something where you are referring to it by IP address, that's how you're referencing it from another device or something like that, then you should do this. You will set that up in your router itself, and again, that's usually as simple as saying, hey, take this device, I see it there, always keep it there, and kind of make that reservation. That is going to do two things. It's going to act like a static because you're always going to be able to go to that IP and know that it's going to be there, whereas normally the IP address tends to stay the same for a long time, but eventually can change. A reservation will make sure it always stays the same no matter what, but also it means that the router won't give that IP address to anybody else because it knows about it. And that's the big advantage of that over a static IP, is that the router itself knows, can keep it reserved, can always give it out. And so even if you do set a static IP on a device itself, where you're telling the device be at this IP address no matter what, then you would want to make sure you go in and make that reservation in the router also, just so it doesn't give it out to anybody else. But again, the reservation alone will solve your problems that way if you can just set it up that way, and that's a better way to do it. Talking about IP addresses. IP addresses are numbers. It's 4 octets of numbers, so it's from 0 to 255, and there's 4 of them. One of the most common ones you're going to see is 192.168.1. something. That is called a Class C subnet, which means it is an IP address where those first 3 octets, 192.168.1, are always going to be the same, and that last dot number is going to be different. In home networking, a lot of the times that's what your IP addressing is going to be, and it means that all of your devices will have those same 3 octets at the same first, and then the last octet will be different, and that means that you can have 256 devices on your network. It's actually a little less because 255 is the broadcast address and 0.1 is the router. don't worry about that so much, but about 250 devices can be on that network and have an IP address that is unique to everything. Remember, everything has to be unique. You can't have two things with the same address. It will cause lots of problems. Now, think about that class C subnet. That subnet means which ones can be different and I can still talk to it. In that one, all of the IP addresses have to be 192.168.1.blank. And that means that any of those devices can talk to each other. To make that indication, they're going to have a thing called a subnet mask. The subnet mask is going to look like 255.255.255.0. So first three octets are all the biggest they can be, and the last one is 0. And that means all these things that were as big as they could be need to match. And then the .0 means I can use it. There's more to subnets. Go down that rabbit hole if you want. But that's basically what that means. The other common IP address subnet range that you're going to see is called a class B, and that is 10.10.something.something. So still 4 octets, but the first two numbers are 10s, and then second two numbers can change. So that subnet mask is going to be 255.255, those two have to be the same, .0.0. And now that means that you have 250 some odd times 250 some odd possibilities of IP addresses. A whole lot more options. Bigger networks can handle that. Some home routers now use that subnetting. Most don't. And beyond this, you probably just don't need to dig in more. If you want to go further past that, you can go look into it and see what it is. But a lot of the time, you can plug in your router, see what it's going to do. It's going to give you its IP address. On mine, my default one, I plug it in, and it's going to tell me it's 192.168.1.1. That's my router. And then it's going to assign out IP addresses 192.168.1.2 through 254. And that's going to let me get everywhere I want to go. It'll assign those out. I kind of don't need to mess with it a whole lot. Now, IP addresses are cool, and we can get to things that way. But one step past that, even more human readable, is a thing called host names. Host names are actual human readable things. Host names tend to not care about case sensitivity, so it doesn't care about capitals and lowercase. But they don't like special characters and they don't like spaces. So a lot of the time when I'm trying to figure out a host name, and you'll see me do this when I'm naming my devices, that I will use a thing called camel case, where I do a capital letter for the first letter of each word, makes it a little easier to human read, but the hostname doesn't actually usually care about that. I could do all lowercase when I'm referencing it, and it'll still work. With the hostname, when I'm talking about local devices on my network, you can think of them a little bit more like a regular web address, but instead of a .com, it's going to be a .local, because it's on my local network. And so that's how you're going to get to your prop controllers, your Nexus prop controllers, usually, is by using the device's name, which is its host name. Whatever you specify there will be its host name, .local. So I earlier had a thing called Nexus prop .local, in a browser, gets me to it. Now, that can fail for reasons. That's its host name. It's using a system called MDNS, and sometimes it doesn't traverse the network fully correctly. And in that case, I may have to fall back to using the IP address. That's not as easy. The IP address can change. The IP address is not as human readable, not as friendly to remember. And that's where the Nexus Controller Manager comes in. And again, I'll do a video on it to show you how it can do the discovery. Whenever I open something from the Controller Manager, it's going to go ahead and use the IP because it's a little bit faster. It's a little bit easier if I have a computer keeping track of it for me to just use that instead of the hostname. But you can do either one. They are kind of interchangeable in most cases. Again, there are things that can make the hostname not function as well. It's easier when it does, but sometimes it gives you issues, and that's where the IP address is going to come in. In your computer, when you're working on your laptop or whatever that you're doing your programming and things on, or your configurations, you can usually set a static IP to get into the range if you needed to. Again, I would suggest you use DHCP from your router, let it do the thing it's good at, let it do the thing it's designed to do, and that should be as easy as you can get to manage things. There's a lot more to get into on networking, but that's kind of the core, what I think you're going to need to be able to get around things here as you're building your escape rooms.